All right, so now we come to part 2, where we calculate the value of z when we're given the percentage. Okay, quick reminder, the table shows the area to the left of z. So it shows this area. And last time what we did is we're given the z, we asked for this area. And this time we're doing a problem that's the opposite of that, where we're given the area, could be the left or the right, and then we ask for the z in between like this, okay? But the table gives the area to the left all the time. All right, so for example, the question is to find z such that it is in the 80th percentile. Okay? For these problems, for the normal problems, always the first thing you should always do is to draw the diagram of the bell shape. So for this problem, I'm going to draw the bell shape. And the question asks for a z such that it's in the 80th percentile. 80th means percentile means 80% are at or below you. Okay, so you're somewhere, we don't know where, and then 80% of the people are at or below you. So this area right here is 0.80. Okay? And that's what it makes, that's what makes it an inverse problem like this, because normally we're given the z and we look at the body of the area for the 80%. And then this one is the opposite. We're given the 80%, so it's already 80% in the body. And then we're looking for the number that's on the axis, on the edge. So that's what we do on the table. On the table, we look for 80% in the area, and the area is here. Okay, the z is on the edge and the area is in the body. So we go in the body looking for the area of 80%, and it's somewhere between these two numbers. Right, closer to this. So our best answer, don't forget how the table is structured. Okay. This part right here belongs to the number 0.84. So the answer is 0.84. So z equals 0.84. That's a 4. All right. Okay. Next example. Find the cutoff for the top 10% of z. Again, we draw a diagram. There's a z that we don't know, and this area is 10%. Okay, so question mark on the axis. Okay, given area. Well, we do know, one thing we do know though, is that as far as the table is concerned, it deals with the area to the left all the time. Right now, we're given the area to the right, so we're going to switch it. We're going to compute what area is to the left. If it's 10% on the right, then over here is 90%, so 0.9 over there. So the area to the left is 0.9. So we're going to look for area of 0.9. Okay. So let's go to the table. 0.9 between these two numbers. Now closer to this one. So it's 1.28. So area to the left is equal to 0.9 and z is equal to 1.28. Okay. You may also notice is that because the table only rounds z to 2 decimals, so a pretty big gap in between there. So the numbers usually you look for a number, you don't find it. You find a number that's very close to it. Okay, now we come to a very common application of doing this kind of inverse problem of looking for z, and that is to find or to compute the critical value of z. Okay? The critical value z with subscript alpha is defined as the z that cuts off a right area of alpha. Okay, so whatever this subscript is, it defines this area that's on the right. Whatever is in the subscript is this area. And the critical value, z with the subscript alpha, is this question mark. All right, so specifically, let's do one specific example. Z subscript 0.05 means the z that cuts off the right tail of whatever number is in the subscript. And the number here is 0.05, so we're going to put 0.05, 0.05. So that's the right tail that we cut off. The area of it is 0.05. And the number that we're looking for, z with the subscript 0.05, is this question mark. So that means we're looking for a number that's on the axis, meaning on the edge of the table. Okay? And again, we're reminded that the table shows the area to the left. So that means we need this area to the left. Well, let's not use a question mark. We need this area to the left, okay? And if it's 0.05 to the right, then it's 0.95 to the left, because the whole thing area is 100% or 1.0. So that means the area to left has to be 0.95. We're going to looking for this z, okay? So we're going to go to our table. We're going to go to our table, and remember, z is on the edge. Okay, the areas in the table. Okay, and we're looking for 0.95. 0.95 is right in between these two numbers. It's right in the middle. So it's 1.64 or 1.65. It's actually 1.645. It's like split the difference. So z is equal to 1.64 or 1.65. Okay? That's how you find the area, find the critical value by looking for the area to the left, even though you're given the area to the right. You're given the area to the right, you need to look for the area to the left, so you figure out what the area to the left equals to, and then you find it in the table. All right, so now we've done two kinds of problems, one where we're given a certain number and then we look on the edge, okay? And then another one where we're given a certain number and we look in the area. So how do you remember which is which, okay? Let's say that there's a 0.10 somewhere in the problem, okay? So does that mean we're looking up this 0.10? Or are we looking up this 0.10 or around it? Okay, which one? And this is a particular problem with those of you who were told in your algebra class that whenever you see a math problem, highlight the numbers and basically just focus on those numbers without paying attention too much to the words. That's bad advice, okay? The words count for a lot of information in a problem. So yeah, the numbers are usually important, but not always. And you have to read the problem so that you know which, like I said here, let's say there's a point 10 somewhere in the problem. So which kind of point 10 is it? Is it a z equal point 10 or is it an area equal point 10? So the way to figure out which is to always draw the normal graph, always draw the diagram, okay? So for example, you have two examples here. Example 1, find probability that z is less than 0.10. This one, find the z that cuts off the bottom 10% of the distribution. So, well, you draw it, and let's see. Z is less than 0.10, so it's something about z. Z is on the axis. So there's something about 0.10, and z is supposed to be less than that. So 0.10 would be on the axis, and we're looking for area. Whereas in example 2, we're asked to find z that cuts off the bottom 10% of the distribution. So the 10% would be in the area somewhere, and we're asked to find the z that cuts it off. So that's how you tell which problem. This one, we're given the number 0.10 on the edge of the diagram of the graph. So we're going to look for 0.10 on the edge of the table. On example 2, the 0.10 is in the body or in the area in the body of the graph. So we're going to be looking for 0.10 in the body of the table. All right, so here's the rule. If the known info is given in the body of the graph, then you look up that known info in the body of the table. Okay, whereas if the known info is on the axis, then, so think of the axis like the edge of the graph, right? Then we also look it up on the edge of the table. So look it up here for the known info. All right, so now let's do this again. Find the probability that z is less than 0.10. So we have our graph like this, and 0.10 is somewhere, probably somewhere around here. 0.10, okay? Z is less than 0.10, so Z being somewhere here, okay? And we're looking for this number. So if you compare this with StatCrunch, then that means it's equivalent to having this 0.10 in the given number, and then we're looking for this value, the area, okay? And so 0.10 is on the edge. So we're also looking for 0.10 in the edge, and the answer is 0.5398. 0.5398 is the area to the left. Okay? It also helps that if it turns out that you're looking for the area to the right, then you'll know that you're supposed to take 1 minus this. But this problem is looking for z being less than 0.10, so it is the area to the left. Okay? And then the other example we were looking at is to find z that cuts out the bottom 10% of the distribution. So 10% of the distribution is the 0.10 at the tail here. And this is what we're looking for. So known information is in the body. So the known information is in the body. The 0.10 is in the body. So it's in the body of the graph. So I'm also going to look for it in the body of the table, and it is at negative 1.28. And this z is negative 1.28. So yeah, always draw the bell shape and the diagram and mark the known information and make it very clearly whether or not the known information is in the area, on the edge, and vice versa. The question mark that you're looking for, make it very clear whether or not the question mark belongs in the body or on the edge. All right, okay. Moving on to part 3.